Hi folks, we're going to take a look at the solution to a pretty typical 2D parallelogram problem, and it's one in which they give us three vertices of a parallelogram and they want us to find the fourth. Okay, so one thing you're going to see me do here is not to draw a Cartesian plane and represent these points accurately. I certainly could, might even be helpful, certainly to check my answer, but the reason why I'm not doing that is eventually we're going to be solving 3D problems involving geometry, and representing points accurately just won't be reasonable. Okay, so it'd be good to get used to drawing more generic diagrams. Okay, so let me just represent 3 points in any location. So here we'll call this point A. So we'll call it 2, -3. Okay, and this will be point B, which is -1, 5. Okay, and then here we've got point C, which is -2, -2. Okay, so again, I don't worry about representing these accurately. Okay, so again, back in grade 10, you might have solved these using rises and runs or slopes, but we're going to solve this using vectors. Okay, so let's see if we can figure out where one of our points would be. So let's remember first of all what a parallelogram is. It's a shape that has two sets of opposite, parallel, and equal sides. Okay, so they don't all have to be the same size, but the opposite ones do, and they have to be parallel. Okay, so if I connect these 2 points, I know I'm going to have one possibility is to have another point here, okay, that allows me to connect with C to create an opposite parallel side. Okay, and then here that would create a parallelogram. Okay, but since these 2 lengths are parallel to each other and the same length, I'm going to represent them using vectors, so from one point to the other. Okay, so let's call this point here D1, so that's, and I'll label it X1, Y1. Now, I could draw a vector from A to B or B to A, but what I want to do is I want to try to end up with my variable point always to be the second one, because remember, when we find the vector joining 2 points, it's always the second minus the first, and I'd really prefer having my variables come first. So I'm going to create the vector CD1, and so this vector here is going to have to be exactly equal to the vector BA, and that's what's going to allow me to form my first equation. So my first point is going to be found by equating CD1, that vector there, to the vector BA. Okay, so let's see what we get. So remember, C to D1, we subtract the second minus the first. So this vector here is given by x1 minus -x2, sorry, minus -2. So that's going to be x1 plus 2. Okay, y1 minus -2, so y1 plus 2. And that has to be equal to the vector BA. So that's going to be 2 minus -1 is 3, and -3 minus 5 is -8. Okay, but since these 2 vectors are equal, it means their x components have to be the same and their y components have to be the same. So I can just equate them. So x1 plus 2 is going to have to be equal to 3, and y1 plus 2 is going to have to be equal to -8. And so you can solve easily. x1, 3 minus 2 is 1, and y1, -8 minus 2 is -10. And we just found our first possible point. So D1 is equal to 1, -10. Okay, now keep in mind, this 1, -10 represents a point. Okay, that's what I was looking for, and here is represented by a symbol that doesn't have an arrow on top. Okay, so let's see if we can find a second possibility here. Okay, so if I still keep with this side here, I see that I could also create another parallelogram by choosing a point somewhere down there. Okay, so I create this side, I have this side, and lo and behold, what do we get? Another parallelogram. Okay, so let me label this D2, so X2, Y2. Okay, and again, I'd really like my vector to be ending at the variable. It's not necessary, but I might as well. So instead of working with the vector BA, I need something equal to that one there, so I'm going to work with the vector AB. Okay, and so these 2 vectors are equal. Okay, so let's set up an equation now. So my second point, so CD2, that vector will be equal to the vector AB. Okay, so CD2 is just x2 minus -2, so x2 plus 2. Okay, and then y2 minus -2, so y2 plus 2. Okay, and that's going to be equal to the vector AB. Now I could calculate it. Okay, second minus first, -1 minus 2 is -3. 5 minus -3 is 8. Or I could realize that AB is just the opposite of BA. And hey, that's exactly what I got. I got -3, 8. I would suggest actually calculating it, just in case you made a mistake the first time. It'll be a good check. Okay, and so now we proceed exactly as before. We know that x2 plus 2 has to be equal to -3, and y2 plus 2 has to be equal to 8. So x2 is -3 minus 2 is -5, and y2 is 8 minus 2 is 6. And so now we have a second answer, d2 equals -5, 6. Okay, so let's see if there's another possibility. So let's change color again. Okay, so I think I've exhausted this side here. Let's work with that side. Okay, so hey, there's a parallel line to BC, but I realize I've already found that point. Okay, so let's see if there's another one. Oh, well, if I take this side, I can create another side somewhere over there. Okay, so I can choose a point somewhere up here, call that D3, so x3, y3. Okay, and again, let's connect these 2 points and those 2 points, and we've got a parallelogram. Okay, so this is why it's a good idea to draw the picture, because you might have sort of found this point D1 twice. So that's why having the diagram, even though it's not perfect, helps you solve the problem without wasting your time. Okay, and so now we're going to solve this in the exact same way. So we have the vector A D3 is going to have to be equal to the vector CB. Okay, so AD3 is just going to be x3 minus 2 and y3 minus -3, so plus 3, and that's going to be equal to CB, so -1 minus -2, -1 plus 2 is just 1, and 5 minus -2 is 7. Okay, so that means x3 minus 2 is equal to 1, and y3 plus 3 is equal to 7, so x3 is equal to 1 plus 2 is 3, y3 is equal to 7 minus 3 is 4, and there we have it. We have our last point. Okay, so it turned out that there were 3 possible answers here, okay, and it could all be solved by using equalities of vectors and finding vectors by connecting 2 points. Okay. So we're actually going to be revisiting this problem because we're going to solve this problem in 3D at some point. Okay, that's it for this one.